Hello, welcome to another Ozcode feature video. This time we're going to look at tracepoints. Sometimes step debugging through your code is not the most effective way to track down bugs. For example, when you're dealing with large volumes of data, you often need a view across the entire data set. You might have dealt with this in the past by adding trace statements into your code, but then the output is plain text that goes into the output window in Visual Studio or to any trace listeners you might have set up. Ozcode's tracepoints are a lot less effort to use and provide much more useful output, so let's take a look at how to use them. This console application contains some code I pulled out of a larger application that runs reports on visitor data from my website. It's supposed to report on users' operating systems, but it's showing zeros for Android and iPhone, and I know that's wrong. The code that does the check is in this operating system check class, and we can see here it's using parallel.forEach to split the lines across multiple threads so it processes faster. The actual operating system check is done in this method at the bottom here. So let's set a breakpoint here and run the application. Now, because I'm using parallel.forEach, this code is actually running across multiple threads, so if I hit F10 to do a step, I actually keep hitting the same breakpoint because I'm hitting it on all these different threads, which makes step debugging through this code even more difficult. So let's add an Oscode tracepoint. The first place we can do this is on the method itself. If I click the quick actions icon, I can say trace every entry to check. That automatically fills out values in this edit tracepoint window. It suggested some default text for me, and below I can see a preview of the text that will be output. That's not particularly useful, so I'm going to edit these variables here. These are just the variables from the code, and if I hit period, I get full IntelliSense on their properties. So I'm going to show entry.userAgent, which is now going to show me this, and bag has a name property, which has gone off the end because userAgent strings are so long. I can close that now. I can work with this tracepoint using the little post-it note icon in the margin here. If I say View Messages, this brings up the tracepoint window here, and now I can continue execution. We're getting a rolling count of the messages going in the top there, and I can scroll down through here and see all the values while the trace is running. So here I can see how many times this method's been called, just under 4,000 times, and here I can see the user agent strings and the names of the collections I'm using to track each one. So 4,000 messages is a lot to look through. Fortunately, the Tracepoints window has this search box. If I type Android in here, we can see lots and lots of Android lines. So our Android count should definitely be non-zero. So let's move deeper into the check method and see if we can work out what's going wrong. I'll clear this breakpoint by clicking on the diamond here. I'll set a new breakpoint inside this if statement to see what's happening when the entry is actually added to a bag. Start the application again. I can add a trace point here using the quick actions on the bag variable. Say trace value of bag. That's created a default trace point for me. Again, I can change this to display the bag name. And of course I want to know what the user agent is. I can add that to the trace point using the data tip. If I hover over entry, you can see that there's a little post-it note with a plus icon beside entry. I actually want to get the user agent name. I can drill down to that and click the icon there, and that adds that to the trace point for me. There we go. So I'll bring up the Tracepoints window again. It's docked down at the bottom now, so I can just bring it up like this, pin that there, and continue execution. I can use the search box while it's running to see actual results as they come in. And we can already see here that the problem is that Android, because it's based on Linux, is getting added into the Linux bag. Just change the search quickly and see what's going wrong with iPhone. And here we can see that the iPhone is being added to the Mac bag because apparently iPhone OS 7_1 is like Mac OS X. So I can fix this problem by going up to my process entry here. There are probably more thorough fixes, but I'm just going to move the iPhone and Android entries to the start of this statement. Okay, let's try this again. Great, now I can see while the program's still running that it's doing the right thing, and I should be getting the right results at the end of it. And there we are. So let's finish up by taking a closer look at the Tracepoint message window. Starting on the left, we've got the time of the message, the process ID, the thread ID, and all these columns have filtering and sorting functionality. If I go up to the top and click this little drop down arrow, I can filter and choose a particular thread, say 8960, and that shows me just the messages from that thread. Go back onto there, clear that filter. Next there's the message text, and if I double click on this, it takes me to the line in the code that triggered the message. And on the right we have the stack trace column, which is a snapshot of the call stack when the trace point was hit. If you want to get more creative with your data, you can click the export button and save all the data in the Tracepoint window to a CSV file that you can load into Excel and analyze there. So now you know all about Oscode's Tracepoints feature. I hope you find it useful. Thanks for watching, and be sure to check out the other videos in the series.